to a demonstration of the basic version of the options pricing model that you can download from my website at optionstaxguy.com or optionstradingguy.com. Here is where you input your option type, call or put, and it's where you reset your current stock price. The default is 100, or you can directly input it here. So we'll reset it back to 100. Now you can reset any of these amounts by using this command button. Any of these spinners will change incrementally the number right next to it. Here's your days to expiration. Typically you'll be going down with that one. Here's the days in the year. Most people will use 365 days in the year for pricing an option. Sometimes I like to use 252 days because it's a little bit more conservative, especially when I am trying to determine what strike price I want to use for a particular trade. If you'll notice down here how it changes when I do change the days in the year. It's almost about, looks like 50 cents right at it. So change it back to 365 and go on. This is where you change your implied volatility, which is a very important component of options pricing. And again, this is where you reset. Now, if you don't like the defaults, if you typically trade stock that is in the 20, 25 or less than $50, you can reset the defaults here. For instance, 50 would be your stock price, and let's say 50 was your strike price, and you typically days to expiration. Okay, and then that's all I want to change. So now when you reset, you're at 50, and reset your days to expiration, be 30 days. So I'm going to go ahead and run this up to 100, and I'll run this up to about 60. Let's go back up to 90. Won't take that long. Now here is where you reset the change in your price increment so you can look at your probability of being in the money. Now this changes by a nickel. So let's change it by $1. And each one of these will increment by $1. In this case, a decrement of $1, and this is an increment. So your Greeks are calculated down here, and it uses the Black-Scholes options pricing model. For theta, you can have a 1, 2, up to 5 day, 7 day, 10, 20, and 30 day theta. So 7 day would be a 1 week theta. 5 day would be a little bit less, so it'd be about a trading week theta. So put on a trade on Monday, see what your theta would be for the entire week. This is where the option value is calculated based on your components. And let's take a look at how this thing works. Look at 110 at a price, stock price of 110. Has about a 50% possibility of being in the money. As we run it down, you can see as time goes by that probability will change along here. Now this one is, because it's the last one, is somewhat of an exception. Now here is where you could, if you really want to model this, I would put my strike in the middle. Let's say it's 100. So now I've got, as the price is $100 and my strike is $100, and I've got 13 days to go, right at the money, it's about a 50% probability. So as we move forward, so with a week to go, or even a trading week to go, Well, the probability of it being at 90 is 0, but up here it's about 100%. The probability of my 100 or my 100 strike put being in the money when the current stock price is 110. Again, at the money, that's really pretty close to what your delta is. So really there's delta at 100 strike, 100 stock price with 5 days to go. Let's watch this move. And it won't go to 0 because that's an undefined days to expiration. So, well, that's basically how the option pricing model works. I hope you have fun with it, enjoy it, and use it to determine some of your strike prices and compare the pricing to your broker. Well, thanks for watching, and as always, good trading.